Hello there, Mr. Sutton here, bringing you the IM376 Part 1 homework solutions on law of sines.
For this problem, I'm trying to find a missing angle, and I'm not guaranteed that this is even a right triangle, so I'm going to have to use something else. I do have an angle and a side across from each other, so that means I can use the law of sines. That would be sine of A over A equals sine of B over B. So I'm going to start with the side angle pair that I know a little bit more about, this side angle pair here. So I've got sine of 22 degrees over 2 equals, and now my other side angle pair, sine of x over 4. So now to get sine of x by itself, which is kind of the first step in this process, we have to multiply 4 to the other side. So we have sine of x equaling 4 sine of 22 degrees over 2. And now I just need to take the inverse sine of both sides to get x. So here I am on my calculator. To get this, I've done second sine, that gave me sine inverse, and then I did alpha y equals n over d to get my fancy fraction mode here. And pressing enter, we get 48.5, and that's going to be in degrees. Okay, so that's definitely one good answer. We can take that one to the bank. However, there might be another good alternate answer as well. With law of sines, you always have to check to see what the supplementary answer, the answer that adds up with this to get 180, is going to be. So if we do 180 minus 48.5, well, let's see here. 180 minus 49, that would be 131. So this is going to be 131.5 degrees. Now the question is, does this answer fit in the triangle with the original angle that they gave us, this 22 degrees? If we add those together, 131.5 plus 22, this is definitely going to be something less than 180. Because of that, that means that both of these answers are in fact correct answers, and we would list them both while giving the solutions. For this problem, trying to find this missing angle in a not necessarily a right triangle, it might be, it might not be. The key thing to focus in on is that we have this angle and side that are across from each other that we know about. So that means we can use the law of sines. Sine of A over A equals sine of B over B. So we're going to start with the side angle pair that we know a little bit more about. Sine of 68 degrees over 7 equaling sine of x, the unknown angle, over the side across from it, this 5 over here. So now we're going to get sine of x by itself. That's going to be 5 multiplied to the other side to do that. So we've got 5 times the sine of 68 over 7. And now to actually get x, I have to do sine inverse of this craziness. Let me do that on the calculator. So on the calculator, I did second sine to get sine inverse, alpha y equals to get fancy fraction. Put all that in, press enter, we get 41.5 if I round that off. So that's one possible correct answer. To get the other alternate answer, which we're going to have to double check to see if it actually works, we need to do 180 minus 41.5. We need the supplement. So that's going to end up being 138.5 degrees. Now, does this actually fit in the triangle with the other angle they gave us? Well, 138.5 plus the 68 that we already know for sure is in this triangle. I'm not sure exactly what it adds up to, but even if you just did 138 plus 60, that's going to be more than 180. Because of that, we know these angles can't coexist peacefully, and we have to actually cross off 138.5. It can't work. So the only answer is just 41.5. For this problem, to find this missing angle, since it's not a right triangle and I have a side and an angle across from each other, I'll use law of sines. So we have sine of A over A equals sine of B over B. Starting with the stuff that I know the most about, we have sine of 30 over 31 equaling sine of x over 32, the side across from that. Let me start by isolating sine of x. I'll just multiply both sides by 32. So I've got sine of x equals 32 sine of 30 over 31. A lot of 30s in there. And now I'm going to have to do sine inverse of all this stuff on the right to get the value of x. So let's use the calculator for that. So on my calculator, I did second sine, and then I did alpha y equals to get my fancy fraction and put all that stuff in there. Pressing enter, I get about 31.1, and that's in degrees. Now, before we call it a day here, remember that law of sines is ambiguous about angle answers, so we always have to check to see if there's another alternate angle that could work. To do that, I'm going to subtract 31.1 from 180 to get the other possible angle. And if I do that, let me use the calculator here. Crunching those numbers on the calculator, that comes out to 148.9 degrees. Now, before we accept this as an alternate answer, we have to make sure this alternate angle actually fits in the same triangle with the angle that they gave us, this 30 degrees. So if I do 148.9 plus 30, is that going to come out to something less than 180? Will it fit in the triangle? Well, yeah, this is going to come out to 178.9, so just barely, but it does fit in the triangle. It's less than 180 combined. So that means that both of these answers are good to go. For this problem, trying to find a missing angle, and I'm not sure that this is a right triangle. It might be, it might not be, can't really tell. So what I'm going to do here, I do notice we have an angle and a side across from each other that we know, so that means we can use law of sines. So that's sine of A over A equals sine of B over B. And in this case, we have sine of 76 degrees over the side across from it, which is 3. And that's going to equal the sine of this x angle here over the side across from it, over 4. Let's isolate sine of x. So we multiply 4 to the other side. That's 4 sine of 76 over 3. And now on the calculator, I'm going to do sine inverse of all this stuff. That's going to get rid of sine and just give us x. So here I am on the calculator. I did second sine to get sine inverse, and then I did alpha y equals to get this fancy fraction in here. Pressing enter, we get a whole bunch of nothing. We get an error. Since I'm pretty sure I entered that correctly, what this tells me is that this x value I was searching for doesn't actually exist. There's no solution to this equation. What that means is basically that this triangle that they drew doesn't actually exist. It's not a triangle. I mean, I can draw anything that looks like a triangle and put numbers on it, but it doesn't mean those numbers actually represent anything that could ever exist.